Hello, we'll have a look at some physics. I want to finish off looking at heat. Last time we looked at specific heat capacity, and this time I just want to finish off having a look at heating buildings and what we do to insulate them and make them better. And then I want to go on and have a look at different forms of energy. So let's have a look at some of those. On this slide, a little picture of how much energy we actually lose from our house. 25% through the roof. That's the one that we started off doing a lot of work on. People had their roof insulated because people know that heat rises. But in fact, we lose more heat through the walls. And we lose more heat through the walls simply because there's more of them. So 35% going out through the walls. The one that everyone forgets is the floor. We put a piece of carpet down and say, well, that's enough for insulation. But in fact, we ought to do a lot more with that. And that is sort of 15%. Windows, double glazing. You hear all the double glazing salesmen going around telling you to sort of buy these wonderful, fantastic windows, and it does this, that, and the other. But we're actually only looking at about a 10% loss in generally normal windows. Yeah, we can lose it through drafts and other bits and pieces if they're badly fitting. And that's sort of another 15%. But it's generally only about 10% on windows. Yes, you can have special glass put on there, which can sort of reflect the heat back in. But most glass does that anyway. Double glazing. The idea is that you have a vacuum between them and it's going to work really well. But you don't buy glass with vacuum. Instead, you buy glass with some sort of gas put in there, normally something like just nitrogen, to try and stop the humidity in there. And they're not perhaps as good as you expect. The largest problem is when we look at something called ROI, return on investment. If you look at the return on investment on windows, it's about 30, 35 years, depending on how much you spend, of course. By which time you probably want new windows anyway before that time. So not really much return on your investment. On the roof, yeah, you're going to make that probably within the year. And with cavity wall insulation, putting that in there, you're going to save that amount of money that you spent on that on your fuel bills in that year. And so subsequent years, you're saving. Foil behind the radiators, you can get insulated foil put behind the radiators. The radiators then aren't heating the wall up, which isn't then heating the outside up. I notice on my house that the temperature just outside my wall is usually 1 degree warmer than if I look at a distance of several meters away from my house. My house leaks. It leaks heat. Most houses do. So that finishes off this little topic on this. What can we do with our house to make them better? Well, let's look at some of those ideas as we look at energy resources and what we can do with those. So I want to spend the time looking at energy resources today, having a look at a whole different sorts of things. We've got a whole load of bits and pieces on energy demands, and these are really quite important. We look at what are the demands on your house. there's certainly an awful lot, and there are some really quite good websites out there which give an good idea, an indication of how much energy is actually being used at this moment. Had I been organised, or well, more organised, rather than trying to get all the equipment ready for this experiments, I'd have actually called that website up. Oh, let's have a go. Let's see if I can find it. What I want to do is I want to have a look at how much energy is actually being used at this moment in time. So if I call my browser up, let's just see if I can work out how much electricity used today. Let's see if I can find what I'm looking for. And the answer is not really. I can't see the right one. I'll come back to this in a minute. I can't find it. So what I'll do is I'll have a look at some experiments with you. And while I'm doing that, my little boy, Paul, will try and find that for you. You know the one I'm looking for? Yeah. And we'll have a look at that. But in the meantime, what we're going to do is we're going to have a look at some different energy sources. We've got power stations. We'll come back and have a look at those. But I want to move on from those and look at alternative energy sources. So let's go over and have a look at those over here. Got a variety of different bits and pieces to have a look at. And we'll see what we can do with these. This is generating energy from alcohol. I've got a mixture here of about 10% alcohol and water. This is an ethanol fuel cell, and I've got a little cap here which will release, and we can collect the liquid coming out down there, and we'll see what we can do. So let's take something like a fan, and we'll see if we can drive this fan using energy made from ethanol. Right, so let's release the valve, and hopefully my liquid will start to flow through. Put this up on a jack to make sure it's a little bit higher so that the liquid's going to flow through. Try and push a little bit of liquid through. Not working well. Let's see if I can just give it a little bit of a helping hand. Got some alcohol water in here.
Let's see if I can just help it along a little bit. Just going to try and squirt a little bit through, just basically trying to prime the system. Let me through. Right, okay. Move the wires in the way. Let's just try a different source just to see if I can get any electricity out. Boring. Let's just try my best just in case. Not hopeful. No luck on that. We'll maybe come back to that one later. Right.
So according to me, working with an ethanol fuel cell, it doesn't seem to work terribly well. Right. Let's just get rid of this ethanol mixture. Because what I want to do is I want to worry about having some water. Can you fill out some water, empty that and get me some, just rinse it out. Right, thank you. We'll try a different one. Because I put some ethanol water in there, I don't particularly want it. So I'm just going to clean this one out. Right. Let's look at a different type of fuel cell. Here we've got a salt water fuel cell. It consists of a piece of magnesium. Do it up to make sure it's got a good contact. And basically a carbon electrode. That's going to go in there. And then what I'm going to do is I'm going to connect the two reds together. If I can find a shorter lead, this will be good. So that's two sides there. Don't necessarily need that, but it will probably make you feel better. We've got then positive coming out. We'll have negative coming out. And I'm going to drive a fan with this. Let's see what we can do. Right, so we're ready to go. What I need is to get some salt water in there. And I've previously made up some salt water. And let's put some salt water in here. And then let's connect it up and see if anything happens. So there we've got something going. We've got just salt water in there and magnesium and carbon. People call this a salt water fuel cell, but in fact, it's really the magnesium and the carbon that's doing the work. And after a while, you are going to need to replace the magnesium plate. I had a spare to show you, put it down. And so you have to replace that because that's what's actually getting used up. Well, it's generating a little bit of air here, and that will go on for a considerable amount of time. So it's actually quite good at that one. So I'll just leave that to the side, chuck it away, and while we're doing that, I'll have a look at a different type of fuel cell. Now, some of you may have seen one of my videos, one of my more popular videos, and this is all about a fuel cell. This consists of basically sort of layers of different materials in here. And what we do is we put water in, and out comes electricity. Or we can run it properly. Right, let's explain how it works. Right. People think it's just going to be powered from water. It's not. It's actually powered by hydrogen and oxygen. And we can combine hydrogen and oxygen to make water, and we make electricity. Or we can reverse the whole thing around. So I could take perhaps my solar cell, and this solar cell I can get sunlight on there, and I can use that into the fuel cell. The fuel cell will then break up the water into hydrogen and oxygen. So I can charge this and then simply connect it up the other way, and it will discharge. I notice it's starting to work a lot better now. It's starting to actually run a little bit faster. Sometimes they take a few moments to sort of build up. Right. Let's set this one up. What I want is to try and set up some storage of hydrogen and oxygen. I'm going to go down my knees so I can do this. So I've previously filled this up with distilled water. This thing's got a little notch in it, so to let water in and out. And what I'm going to do is I'm going to store some gas in here. So I'm just going to fix this to the bottom. And then I'm also going to put a tube to connect this. And I've made it so it's just under the water level. Right. We're now ready to prime this. And what I'm going to do is I've got some more distilled water. And I'm going to fill up my little syringe with a bit of this. Now I have to load up both sides. So this is the black side,
which is hydrogen. And what I'm going to do is I'm just going to connect the tubes very badly together with my fingers, just holding them. Try and do this so you can see, but probably so you can't. And what I'm going to do is squirt some water in here. I'm going to do it the right way around. I can hold it better. So I'm just going to hold two tubes together, push some water through, and hopefully I'll get some water going through. Paper towel would be better. Yeah, I'm not getting it through. Okay. Stick this in. It's usually the easiest way in the end. There we go. I'm pushing water through into the hydrogen side. And then I'm going to block this up. So that tube is now full of water. Right, we'll do the same with the oxygen side. We'll push the water through, and you might see the bubble going through here. Round into the oxygen side. And then I'm just going to take that off and seal it up. Right, this is my fuel cell now ready to go. Quick mop up. And we're ready. Now, what I would normally do with this is I would normally now take this one outside and I would power it with the solar cell. So we've got our solar cell. We have the sunlight shining on it. I'm going to put the black side on one. I'm going to put the red side on the other. And this, with the sunlight on it, is going to charge this. And we're going to get free energy. But I'm indoors today, so I can't do that. So I'm going to have to cheat instead. And whereas I would normally use this outside charge, today I'm going to have to resort to using a battery to do the charging. Which is a bit pointless really, but it's because I haven't got solar power easily available. I do have wind power, but I haven't set that up yet. Okay, so let's turn this on, and as it starts to work, we can see a gas running through, and they're arriving in these little chambers, and you'll see the chambers, if Paul can focus on them, you'll see the air levels in those start to go. I'll flip it along a little bit. Does that help you? And we can see that this is the hydrogen. This is at 10 at the moment. The other one's about 5. We're getting about twice as much hydrogen as we are oxygen. Now, this is not surprising because we're splitting the gas, the water into two gases, H2O, so we're getting twice as much hydrogen as we are oxygen. And we're down at 15 now. I'm going to take it to fill this hydrogen right up. So we're going to make about
30 centimetre cube of this hydrogen gas. Now, once we've done this, then we've just charged our fuel cell. You needn't, if this were a car and it was running off of just a fuel cell, then you might go into your local friendly hydrogen station, much like a petrol station, and you may take out a container of hydrogen from the hydrogen station and literally plug it into your car and you're ready to go. We don't have those at the moment, but then when the automobile started, trying to find a petrol station was also equally difficult. We're virtually down at 30 here. When I get too much, then simply there's a hole at the bottom where the water's coming out at the moment. And what will happen is bubbles of hydrogen will come out there. And when we get to that point, I'm going to stop. And I'm expecting a bubble of hydrogen any moment now. Looking here to see it coming out. There we are. There it's coming out. And so I'm simply going to unplug this and stop it. Right. We're ready and raring to go. Let's take my fan. And we're now not using this cell anymore. So I'll take that one out. It looks a bit grayer than it was before. I'm doing well for knocking things over. Trying to keep the electricity and water separate. Right. Let's go back to our fuel cell. The fuel cell's fully charged. We don't need to leave it for any time. We don't need to do anything for any time. Now, what we just do is we plug in red to red, black to black. And then immediately it starts working. Hydrogen is now coming out of this cell, oxygen out of this cell, joining in the fuel cell, reacting, producing water and electricity. So we're making here electricity and water. This has a good side effect that pollution is absolutely zero. And when we're making this hydrogen, if we can do it intelligently, using things like solar power, then it can be really effective. And it doesn't take very long to produce hydrogen. The biggest problem with hydrogen is how to store it intelligently. And this is one of the big problems that we actually face. So here is a fuel cell trying to power something. Let's stop this for a minute. The fuel cell just stops. It's ready to go, much like this one. I just stopped them, but by putting the thing back in, it will work straight away. How else are we going to get power? Well, the obvious thing would be something like wind power. And I've got here my little device. And what I'm going to do is I'm going to connect this to my fuel cell. I'm going to see if I can make some more hydrogen. So let's connect this up. And what we require is a little bit of wind. So let's turn on a little bit of wind.
not sure what definition. And what I should be able to see now, if this is going, let's give it a little bit more welly. Then we've now got, unfortunately, I've brought in some portable wind, which is otherwise known as a fan. And the fan is driving my wind turbine. If I had this outside, it would be driven by the wind, it would be possibly anything. And this is now producing the electricity, and we are now creating the water in here being split into hydrogen and oxygen. Right, we'll just shut that in. To show that this is actually producing some electricity, let's try this connected up to an LED. Let's just see if that works. Or, yeah, I can do it with a fan. Do it with a fan, really. So if we put the fan on now, what I want to try and do is to show you that fan is actually being driven by the wind, and probably the best way of doing that is to isolate it. And I'm going to use here my iPad here. So if we have a little bit of wind, just about going there. A bit more wind, please. There you can probably just about see that this is being driven by the wind. Not terribly effective. And we're losing an awful lot of power. We may not want to always use this type of fan. This is basically wind turbine, it will turn, and you've seen a lot of these probably around the countryside. They're quite good, but we do have a few problems. Largely they get turned off, the wind gets too much. We can do this with a smaller fan, and this one is a vertical wind turbine. It works better in any particular direction. So let's just put some air on here, some wind on here, and we'll see if this can do anything. It doesn't put out as much power as the other one. So if I turn it on, we can get this one going, and we should see we can get some LEDs lit. There we are. I've got two different resistances, and they work differently. So let's have this one. We'll see that lighting up. And if we get this one online, we can see that one is also generating some electricity. But barely enough to power a little fan like that. So we've got different types of fan. A lot one place to go. So this one's spinning quite madly, but it's not making that much electricity. It's not making enough electricity to drive these LEDs, which are more powerful versions of those. So not really as powerful, and certainly not powerful enough to run a little fan like that one, or worse, the big one. You'll notice the little one is powered by the wind here. This big one, even that amount of wind is not really enough to drive that one round, such as its sort of power requirements. So we have to be aware of how much energy we get out of these different things. So wind turbines, they're really good. They provide now quite a lot of the UK's wind power. Lots of electricity generated that way. Most of the solar arrays, these have a significant problem. And the significant problem is, of course, they don't work at night. And with the vagaries of the UK weather, they don't actually work every day of the year anyway. I've got solar panels on my roof, and some days they're very good, and other days they are not as successful. This wind turbine here has 4 blades, but this kit enables me to make it with 3 or 2, and then we can investigate how it's different with the different blades. It's incredibly simple, however, to see how it works. And I thought I could show you how one of these works. What I've got at the bottom are a couple of coils, and these coils are connected together to the two terminals. So we've just got 2 coils there. Underneath here, I've simply got 4 magnets. Blue being north, the red being south. And as this spins, it induces a current, voltage in the coils below. Really incredibly simple. Cheap to make, and there should be no reason why we don't see one of those on every bus stop, every sign, and power it that way. But we don't. So there we've got a few. I'm sorry the ethanol fuel cell didn't work. This is sort of problems that I have with technology sometime. We'll try once more, but I'm not hopeful. I'm just going to try. Once more. See if it's working. No, not particularly. Right, okay. So we're not going to try that. Ethanol fuel cell today. No go.
So that's had a look at a few different sorts of systems. We've looked at, then we've got wind power, something that's fairly easy. Now, what I'm going to do is I'm just going to go through some of those. And while I'm doing that, I'm going to get my son to see if he can look up the website, which he'll tell me what it is. Ah, right. Okay, he's found it for me. It is. Hang on. Grid Watch. That's the name I'm looking for. Right, gridwatch.co.uk. Let's see. This shows us what the demand is and what's being used. So our demand on the time that I'm doing this is about an hour ago. So on the 9th of April 2020 at approximately 11 GMT, which is about 10 minutes ago. GMT, we're on BST. My son is now agreeing with me. Demand is 29 gigawatts. About 11 here is being provided by renewables, 39%. Nuclear stays more or less constant, about 15%. The CCGT are the efficient gas turbines. We've got biomass. Coal is producing just 2%. Wind here at 8%. Solar doing very nicely today. It's a lovely day at 21%. No oil. And a few others imported from France and wherever. When we got a negative sign, we're exporting it. And if we look at our averages, we can see how we're actually doing. The base is where we're getting most of the stuff from at the moment, so we can look at any of these 10-minute averages to see where we're getting. So nuclear, you can see here is 4.48, and we can see what we're producing and where. We can look at yesterday's averages, we can look at the month averages, and you can see these make beautiful spikes, and it gives you quite a lot of information. Grid Watch, really good way of having a look at what's going on. So I want to finish really having a look at energy demands. They're coming from you, mobile phone, TV, computer, games console. All of this requires electricity, and that's being made by various sources. Now, if we look at our alternatives to this, we've got wind power. Now, we can think of some pros and cons for wind power. Basically, the wind is free, so we've only got to supply the machine, but it doesn't blow all the time. We can have wave power. Now, I live in Hemel Hempstead, which is a fair way from the sea, so wave power is unlikely to be a good source here, but I grew up near the coast, and wave power there could provide a lot of energy. And I haven't seen very many days when there haven't been any waves. Hydroelectric power, we've got Wales with its hills, we've got the Lake District with its hills collecting water in dams, and what we can do is release that water and then later pump it back in. Seems a waste, but it means we can get lots of electricity quickly when we need it, and then we can reset it. So we're not actually making any benefit from that. If you live in a better country with more mountains and better water coming down, like Scotland, then we can do and produce much more hydroelectric power permanently. Tidal power. There's been talk about putting a barrier across the River Severn for very many years and to basically try to power the water coming down from the River Severn to produce electricity. When the tide's the other way, the water rushes in up the River Severn. We may have heard of the Severn Bore, and this produces again electricity. So we can get electricity produced at going towards low tide and towards high tide. The bit in the middle doesn't tend to work very well. My favorite, energy from solar. I have solar panels on my roof, and these produce probably about half of my electricity. At night, of course, they don't do any, but on a lovely sunny day like today, I'm producing all of my electricity by solar. I can also use solar hot water, and these are solar panels that just heat my water, and this is pretty good for the summer and spring, part of the spring, part of the autumn, because I don't need to heat my water up because all that energy is being provided by the sun. Geothermal energy, if we're going to somewhere exotic like Iceland, they're sitting on a fault line and they've got oodles of hot water. But if you live in Bath, you'll also know we've got hot water in this country. So we should be able to do some geothermal energy using the heat from inside the earth to heat water to drive a generator. So a fair number of ways of trying to get rid of relying on energy from fossil fuels. And I suppose nuclear fuels as well, because nuclear, we've only got so much nuclear fuel, and that's not really renewable, but it does give us an awful lot of power per kilogram. Fossil fuels, yeah, they're pretty good. Coal, oil, gas. Gas is probably about the most efficient and can be used the easiest to get going. Oil next and coal the worst. We're moving away in this country from coal, and we're moving away largely from oil. So what's our big energy issue? The big energy issue is very simple. We all want power, and we all want too much power. Power as in electricity. Coal, oil, gas, they're running out. Nuclear will run out. So we've got to move to the renewable energy sources. Wind. The UK's made a large investment in wind power, and as we saw, we're producing here now 8% today of our wind is providing the electricity. Our renewables at something like about 39%. So that's looking pretty good. We may be able to try and get this above 50%, hopefully soon. Depends on the day, doesn't it? If it's windy day, lots of electricity. Sunny day, lots of solar, lots of electricity. Miserable day, foggy, hardly any solar, hardly any wind, and it didn't work. So we have to think of other things. Having said that, England and Ireland, it's pretty windy, so wave power might be an important way to go. We've got in this country nearly all of these working. Tidal power, not. Geothermal power, not very much. Our big energy issue is that we are using too much electricity. We need to be more efficient in using our electricity. We need to buy devices that are A+++ rated, so they use less electricity. It's a good idea to buy it that way. It's going to save you money because your electricity bill is going to be lower. Perhaps if we switched off lights, not leaving them on. How many of you leave your room and leave the light on? Yeah, hopefully you've moved from incandescent bulbs to more efficient bulbs. My house now uses LED light bulbs, and the LED light bulbs are using about the same amount of electricity that 2 bulbs in my house would have used previous to this. Any other things? Well, cars. Can we get away from petrol? Can we go to electric cars? Sounds a good idea, but where are you going to get that electricity from? If we're getting that electricity generated by oil, coal or gas, then it's better and more efficient to put that fuel in the car. If we can make it from renewable, on the other hand, much, much better. Renewables aren't free. You've got to pay for the equipment. But if they last a long time, that's a small price to pay. So hopefully that's some of the ideas about energy sorted out. Next time we come back to looking at physics, we'll look at particles in work. I'll see you next time. Take care. Bye-bye.